Hello, my name is Gary Weatherly, and I'm a professional scenery and lighting designer and have designed over 400 productions in theaters all over the Southeast. I'm also an educator and just recently retired from Mountain Brook High School, where I taught for 23 years. I'm going to present a workshop that's introducing basic stage lighting. Although this isn't a workshop about lighting design, the information that I'm going to present is knowledge that you're going to need if you want to become a lighting designer. Lighting basics start you down the road of understanding the different elements for lighting for the stage. Now, experience is the most valuable skill you can get in lighting. So I'm encouraging you to get out there and help out with your school productions. Set up those lights for the show. This will get you familiar with the instruments and the specialized equipment for lighting the stage. When you get involved in lighting for a show, you are very much a part of the art of theater. You are contributing a vital role to the staging of the show. At the beginning, now it seems that a lot of this information is very complicated and technical, but it is important to understand and to know these basic elements. You can use this knowledge to bring the magic of theater to your audience. The first basic that you need to know is a basic understanding of electricity. Unless you are outside and using the sun as your light source, all indoor lighting is dependent upon electricity to operate. Most of you have had some sort of basic information about electricity from your science class, or maybe you've had a physics class where you studied electricity. I will hit on the high points and the basic vocabulary terms that you need to know when you're encountering stage lighting. First, let's just talk about what is electricity. As you know from your science classes, it's a flow of electrons that's forced between 2 points. This force is usually created through a generator, but could be from a battery. The electrical force that we're familiar with is the electric current that comes into our houses and into the theater from the power company. This pressure that's exerted to make the electrons flow is measured in volts. The most common voltage that we are familiar with is 120 volts. Most household stage current is rated at 120 volts. Next, the flow of these electrons through a wire is called a current, and that is measured in amps. And the wires that the current passes through create some resistance in allowing those electrons to flow, and that resistance is measured in ohms. Now, that's a lot of technical terms, so I'm going to kind of explain it. This is how it works. Electricity is generated, usually from the power company. And for it to flow, it has to have a circuit, wires, to be able to flow. Now, have you noticed that batteries have a positive and a negative terminal? The push of the electricity comes from the positive terminal, and it wants to flow to the negative terminal. A circuit is created when you connect a wire from the positive terminal to the negative terminal. To use this electricity, you have to place an instrument, for example, a light bulb or an electric motor, in that circuit. Electricity would then flow through the light bulb, making it light up, or through the motor, making it work. Now, how do you control this electricity? There are really only two ways to regulate the energy of an electrical circuit. One is to regulate the voltage from the source. Now that isn't a possibility because the power company supplies everybody the same voltage of power and will not vary it. Therefore, we must use a second method by introducing resistance to slow or reduce the amount of current going to the instrument. These electrical elements can be expressed in a formula so that you can figure all of this out. The resistance, or ohms, is equal to the voltage divided by the current, or the amps. Now, there is one other measurement that needs to be considered when we are talking about electricity and lighting. That is how much power is required to make it work. Now, not enough power will make the motor go slow or make the light bulb very dim or not work at all. This measurement is called wattage and also worked out in a formula. The watts, the amount of work, is equal to the volts times the amps. Now, most of what I've described so far had the current traveling in one direction, but in this country, our electricity is applied in the form of alternating current. That just means that the electricity flows in one direction until a maximum is reached, and then it reverses and flows in the other direction until a maximum is reached. This is called a cycle and is repeated constantly. The number of cycles per second is called a frequency and is measured in hertz. Each country in the world has its own frequency. The United States has a standard frequency of 60 hertz. Now, electricity is dangerous. You have probably gotten a bad shock from an exposed electrical wire or electrical short at some time in your life. If conditions are right, the electrical shock could kill you. There are built-in safety measures to help protect you from a lethal shock. If you've looked at lighting cables or even your household extension cords, you have probably noticed there are 3 conductors. There's one that is the live conductor, where the electricity flows, a neutral, which is the return conductor, and a third conductor that is called the ground wire conductor. Wiring standards allow for electricity to escape to the earth. I'm talking about the planet Earth, the ground that's beneath our feet. This electricity can escape there at any time. The earth will accept it. Everything metallic in electrical wiring systems should be connected to the earth via a ground conductor. This allows a circuit malfunction to escape to the earth and eliminating a potential of a lethal shock. Now, fuses are another protection that is built into most wiring systems. This is an item with a short length of wire conductor designed to melt if too much current passes through it. This protects the rest of the current from damage. This usually happens when there is a fault or short in the circuit, lowering its resistance, or can happen when too many appliances are on one circuit. Fuses usually can be replaced with a new fuse of equal voltage and current rating. But most theaters and modern homes have higher amperage demands, so circuit breakers now perform the same function as fuses. This prevents an overload of the system. The electrical breaker cuts the electrical circuit if there is a current overload. Cables are how electricity is carried from the source to the instruments. Flexible extension cables are used to connect instruments that are not near a power connector. cable should consist of 3 cores or small cables bound together in a protective sheath. Each wire in the cable is color-coded and performs a different function. These colors should inform you as to which wire should be connected to which terminal of the plug or appliance. Now, the standard colors on these wires are live is red or brown. Neutral is usually black or blue. And ground is green or green and yellow. Cables also have current limits, and this should be taken into account when you're planning your lighting for a show. For example, you do not want to overload the number of instruments that you use on one cable. It could cause the circuit breaker to trip, or worse, burn the wiring insulation, causing a short and possibly a fire. Next, we're going to look at the equipment that produces and controls the lighting on your stage. Lighting instruments have made a lot of changes in the recent years, and some of the schools have been able to get their systems upgraded and modified to be able to use these new fixtures. But most of you are still using the conventional or traditional fixtures. There is a vast array of instruments that will perform differently, and we will talk about them. But there is a basic design to all luminaries. They all consist of an outside container that holds a light source. This is called a lamp, with a reflector behind it to help focus the light beams out through an opening in the front of the container. This opening usually has some sort of lens that can alter the light beams by changing the distance from the light source to the lens. Additionally, features are added to the container that create the different types of fixtures that you can use. Now, the main type of conventional fixture used in theatrical lighting are ellipsoidal spotlights, fresnels, yes, it's a French word and the S is silent, floods and cyclights, and parkans. Now, all of these fixtures have one thing in common. Each has a light source. In theater, we call this special light bulb a lamp. There are many different types of lamps, different base mounts, different lamp shapes, and different wattages. You want to make sure that you understand the correct lamp type that fits that fixture. There is usually an optimal type and wattage for each fixture. Putting in the wrong lamp could minimally degrade the efficiency of the instrument and at most damage the instrument because of misalignment. Consult your manufacturer's specifications to make sure you use the right lamp. Most of these lamps burn at a very high wattage rate, sometimes as high as 2,000 watts, and at very high temperatures. Therefore, it's important to be aware that you must not touch the glass part of the lamp when you are changing a burnout. Touching the glass leaves oil residue from your hands on the glass. When this is heated up to the extreme temperatures, when it's in operation, it will degrade the glass structure, causing minimally a shortened lamp life and a burnout, or worse, an explosion of the lamp inside the instrument. You must be very careful in replacing these lamps, and do not touch the glass part at all. When changing a lamp, there are 2 basic precautions that you need to follow. Always unplug the light fixture before attempting to change the lamp. Make sure the lamp is cool before you try to handle it. Always protect your hands when handling a blown out lamp. It could shatter in your hands when you're removing it, so use a glove or a cloth to help remove those blown lamps. Next, let's explore the different types of fixtures you're probably going to have in your inventory and the particular functions and the qualities of these fixtures that are going to provide stage lighting. The first fixture is an ellipsoidal spotlight. They get their name from a particular design of the reflector in the spotlight. These reflectors are very efficient in redirecting light beams through the opening in the front of the instrument. They are commonly called LEGOs. Once upon a time, LEGO was a particular brand name for this type of spotlight, and the name is used now to define all the lights of this nature, much like Kleenex is used to define all facial tissues, and Coke is used to define a carbonated soda. These instruments provide a hard-edged beam of light of a fixed size. The quality of the beam and the hardness and softness of the edge of that beam can be changed by the lens system in the front of the instrument. There are knobs on the front of the instrument that adjust the lens to change the focus of the beam. Inside the instrument, between the lamp and the lens, there is an aperture or gate for the light beam to pass through. This sharpens the light. There are also 4 independent shutters built into the gate that allow the shape of the beam to be altered from each of the sides. This gate also allows for the insertion of gobos, which allow the projection of images or shapes in the beam of light. It also allows for an iris unit to be inserted that can further control the circle shape of the beam as it is projected. Irises and gobos are not already part of the instrument, but can be put in and inserted when needed. The front of the instrument has a slot that a color frame can fit into to be able to color the light beam with gel medium. This is a hard edge beam instrument. It defines a certain area on the stage, and it has a very strong effect. It can be used in many different ways, for example, to draw focus to a particular area of the stage or to pick out an actor in sharp contrast to their surroundings. A follow spot is a very large ellipsoidal spotlight that is mounted on a stand and that can allow the operator to manually move the light to follow a performer. Its lens system can also move and to adjust the quality of the light output. It usually has an iris unit already built in and has a device that will cut the light without turning off the instrument. Most follow spots also have flip-in color changers which allow quick color changing in the instrument. These instruments allow an actor to always be highlighted wherever they go on stage. Follow spots are very expensive. They're probably the most expensive instrument that you will have in your theater. The Fresnel gets its name from the French inventor who designed the step lens for lighthouses. He cut away some of the glass to create multiple convex curves to help focus beams of light in a straight line. He figured out a way to cut away the glass to decrease the weight and the bulk of the huge glass lens used for the lighthouse. Theater lighting designers saw this as beneficial for stage lighting instruments as well. The beam is somewhat diffused because of the lens and therefore does not have a hard edge. This is a much simpler light instrument than the ellipsoidal spotlight. It doesn't have the built-in shutters or the iris, but the light source and the circular reflector that's inside the instrument usually is attached to some sort of track and can be moved inside the instrument to allow the light to change from a spot to a flood. Because there are diffused edges on the beam, this instrument is very easy to blend with other lighting instruments or additional Fresnel lights to cover large areas. Although there are no internal shutters, there are devices called barn doors that can be attached to the front of the instrument, in front of the lens. These are crude-like hinge shutters that can be bent to block the light on each side of the instrument. The fixture also has a slot in front of the lens to hold color medium. Fresnels are usually available in 500, 750, and 1000 watt sizes. You can even find some 2000 watt sizes. These instruments are usually hung overhead on the stage electrics because they usually have shorter beam throws than the ellipsoidals. Our next fixture is a flood and a cyc light. These floodlights are used to cover large areas, hence the name flood. They are very good at lighting backdrops or cycloramas evenly. The instrument is very basic in structure. There is a lamp and a reflector. There is a slot to hold a color frame in the front. Floodlights and cyc lights look almost the same. The floodlight reflector is symmetrical. It evenly throws the light around in both directions. The cyc light has a reflector that is asymmetrical, so the light can be hung close to the backdrop and the reflector would distribute the light evenly from the top to the bottom. Floods can be mounted on the floor to shine up onto the scenery, and when they're mounted to the floor, it's called a ground row. They can also be mounted to the front of the stage on the floor and light the actors from below, and this is called footlights. Next are parkans. Parkans provide a strong parallel beam of light, and this light was introduced during the 1970s and became popular with the rock and roll tours because it's a very simple and durable lighting fixture. It's also very cheap to produce, it's lightweight to carry, and it's great at projecting deep colors. The instrument is basically a cylinder with a sealed lamp unit that has a reflector and a lens already built into the lamp unit. This lamp unit looks very much like a car headlight. The lamp comes in a variety of beam widths from very narrow, medium, wide, very wide, and a variety of intensities, usually either 1000 or 500 watts. They are usually defined by a number which refers to the diameter of the lens in eighths of an inch. Most theatrical parkans are par 64s. Since the lens is built into the lamp, there is no lens system for the instrument. There is a slot in the front of the instrument to accept a gel color. This instrument really is very simple. It's a metal cylinder with a lamp unit mounted in the rear. It produces an oval-shaped beam, and you can move the lamp head and turn it in different directions to change the directions of the oval-shaped beam. Now, some companies have enhanced the technology and the design of the reflectors and lamps for a lot of these conventional instruments and have improved their efficiency and light output. Companies like ETC, Altman, Chauvet, Elation, Leviton, Philips Strand, they all offer more energy and light efficient instruments and lamps. A lamp was developed that runs at 575 watts for these new fixtures, and the light output is more than the older conventional instruments of 1,000 watts. Moving lights are another innovation that is beginning to find their way into school theater spaces now. These instruments are heavy and bulky, but are also very versatile. They can be bought as a wash instrument, or they can be a spot instrument. Now, the wash instruments work much like a Fresnel works in principle, but with the versatility of a motorized yoke that can point the instrument in any direction desired, adjusting the spot and the flood of the instrument instantly, and changing the color of the light beam, and it also has a built-in strobe effect that can be controlled from the control board. The spot instrument of these moving lights works much like an ellipsoidal instrument. The light fixture is on a motorized yoke and can be aimed in any direction desired. The light beam can be adjusted into a sharp focus or diffused. The iris can adjust the beam size. Colors can be added, and there are multiple gobo patterns that can be added to give the light texture and project patterns, as well as to animate these patterns with spinning and movement. But there is more. Today, new instruments are being developed with LED technology. They use a lot less energy, and the lamp life is extensive. The LED technology first developed a function much like the floods and the Fresnels. Recently, the LED technology has developed to create stronger beam spot type instruments to function more like the ellipsoidals. These instruments are still much more expensive than the conventional features, but there are arguments that the energy savings over time can rationalize their initial cost. Using these technologies of moving instruments and LED instruments demand new technologies of control as well. We will talk about that soon, but first we need to talk about the basic functions of control for conventional lights. Most schools still depend upon conventional lights as the workforce for their theater productions. Plugging in an ellipsoidal spotlight in a wall socket will bring the light to its full 1,000 watt intensity, but the only way that you can control it is to unplug it. You will also have a problem finding enough wall outlets to plug in all the instruments that you need to light the stage. Stage lighting systems need large amounts of power and a way to vary the amounts of light coming out of the instrument. This is the controlling and power supply system that is installed in most theaters. The first element of this system that you will encounter when you are hanging and adjusting the fixtures for your show. The instruments are usually hung on special pipe battens over the stage called electrics. Most stages have at least one overhead electric, but often more equipped stages will have 2 or even 3 pipe battens that are outfitted with raceway power strips with multiple circuits to power the instruments hung on them. There are also usually catwalks or an added electric batten as a front of house of the stage. This is also fitted with a raceway of circuits so that the fixtures can be hung and powered to supply light directly toward the front of the stage. These circuits are often numbered, and each circuit is connected to the same numbered dimmer in a dimmer rack located in a closet or room where the outside electrical power is connected. Dimmers are the means by which the lighting can be controlled. Each light in each individual circuit on the stage is connected to a dimmer which controls the electricity going to that plug. Theaters have racks of dimmers. They need to be located where there is enough ventilation to keep them cool and to prevent the humming noise that they give off when they are working. Each dimmer has a circuit breaker that protects it from being overloaded. Each dimmer has a working capacity, and it is important not to overload the capacity of the dimmer. Most dimmers have a 2,400 watt capacity. That means that you can put two 1,000 watt instruments on that one dimmer. Any more and you will overload its capacity and make the breaker trip. To make the dimmers do what you want, they are connected to a lighting control board that issues commands to the dimmers and controls the intensity of the lighting fixtures on the stage. The control board can be very basic to something that has many added features and commands that allows you to do many complicated effects with the lights. But the main function of all lighting control boards is to give you a way to assign the dimmer to a channel. Usually that channel is a slider on the fader of the control board that you can then manually slide up and down so that information is transmitted to that dimmer to control the power supply to the circuit, which controls the intensity of the light. On very old systems, this assignment was usually done manually at the patch panel. Hardly anyone has that anymore, and most control boards can now do that patching electronically. Most schools have boards that will allow you to do much more. For example, multiple dimmers can be grouped into one channel, or multiple channels can be grouped into one submaster fader. Some boards can be set up as a two-scene preset board with an A side and a B side. Channels are preset at prescribed levels on the A side for one cue, and a crossfade lever will go into the settings on that A side. The channels of the B side are then set at a prescribed level for the next cue, and the crossfader will then bring down the levels of the A side and bring up the levels of the B side at the same time, changing the lights for the next cue. Now, today, most boards are computer boards, and they allow you to electronically patch the dimmers into the channels. They allow you to assign channels to submasters, and they will allow you to set up cues electronically on the computer screen. You will be able to crossfade from one cue to another cue by pushing a go button on the control board. The computer will allow you to assign fade times to the cues and allow you to set up effect routines to be embedded in the cues. Computer control boards have revolutionized lighting control. The computer can record and recall a list of preset cues, control levels of hundreds of channels, all moving at different times and different rates. The complication of the cues and the sheer number of cues that can happen in a show are limited only by your imagination. The last element I will talk about is placing your lights to light the stage. A Yale College professor, Stanley McCandless, developed a modern approach to lighting the stage using a 3-point lighting system to light the actor on the stage. He lit the person with two lights from the front that were positioned 45 degrees off center and at 45 degrees above the actor's head. In one of the instruments, he put a warm gel, and in the other instrument, he put a cool gel. He hung one more instrument behind the actor to light the actor from behind. This method best represents the lighting that a person would have in the natural world. We still use this method today to get the most natural look on the actor on the stage. Thanks for watching my Lighting Basics talk. I hope you get out there and help with the lighting of your next school production.